Hello everyone. So in this question, you can see we are going to discuss question number 16 of ISS 2024 that belongs to your set A. This question says that let ut and vt be the moment generating function of two random variable x and y respectively, and vt is equals to u of log of ut. If expectation of x is 2, then we have to find the value of expectation of y. So everyone, like generally while discussing about moment generating function, we use the notation mxt and myt. So right now you can see different notations are given to us, but just to avoid confusion, I am just going to take the same notation, but later we will just change it. Okay, so it is up to you whether you wanted the same notation that is given in the question. It is your choice. But now I am just going to take mxt. You can see mxt be the mgf of the random variable x I am choosing, and myt be the random variable of y I am choosing. So at the place of myt, whose value is already given to us in a form of mx of log of mxt. This is what I have chosen the notation by my own. This is representing the moment generating function of y. Now what is given to us? We have given already the value of expectation of x, which is obtained by differentiating the moment generating function with respect to x and putting t is equal to 0. So it is given in the question 2. And what we have to find expectation of y that can be obtained by differentiating myt with respect to t, and at the end we have to put t is equal to 0. So this is what we have to find here. Now the first thing is that everyone, we know what is the formula of mxt. So we know that mxt is equal to expectation of e to the power tx. This is the formula, and myt is already given to us. Now we have to find the value of expectation of y, and whose formula I have already written here. Now see one thing, you can see here above, mxt is equal to log of mx of t here is given to us, but I'm just going to suppose this log of mxt is the function of t. So we are just supposing that f of t is equal to log of mx of t. So now from here, the value of myt will be myt is equal to mx of f of t. Okay, now after that, we are just going to differentiate this my of t, because we want to differentiate it here and we have to put t is equal to 0 to get the value of expectation of y. So m dash y of t will be equal to m x dash of f of t, and again we have to differentiate the function of t. Now from here, what like step by step I'm just going to show you. So first point is that we have to find the value of f of 0. So f of 0 will be log of mx. Now at the place of t, I have to put 0. And you already know that log of mx0. What is the value of log of mx0? It is 1, and log 1 is equal to 0. If you are still wondering that how I got mx0 is equal to 1, I will show you here in the side. But also if you want to, if you want more detailed information about this, you can join my live classes for ISS. So here you can see everyone, mxt has the formula expectation e to the power tx. And see, I am just going to find out the value of mx of 0. That means I have to put e to the power 0. And you know e to the power 0 is 1. So finally I will get this 1. That means mx0, the value of mx0 is coming 1. So I have substituted it here and log 1 is equal to 0. Now what is the second thing that I'm going to find is the value of f dash of t. So first of all, I have to differentiate this value with respect to t. Suppose this is t now at the place of 0 and I have to differentiate it. So what I will get? I will get 1 upon mx of t, and again I have to differentiate it with respect to t. Right, so I got this. Now at when t is equal to 0, what I will get? F dash 0 I will get, then mx dash 0 and mx0 I will get. Now what is the value of mx dash 0? Okay, so you know this is representing what? This is representing the value of expectation of x, because when we differentiate the moment generating function with respect to t and we put 0 in it, we get the value of expectation of x, which is already given in the question 2. And the value of mx0 we already got here in the side, you can see, which is 1. So finally the value of f dash 0 we are getting is 2. Now the third point is that to find the value of mx dash mx dash of f of 0. Okay, so from here everyone, you know, f of 0 is coming what? F of, you can see the value of f of 0 is 0. So we are going to substitute here and it will become mx dash of 0. And we know that like differentiating mxt with respect to t and putting t is equal to 0, it will provide you the the mean of the random variable x, which is already given us and which is 2. Okay, now what is the next thing we are going to do? Like we already got these three things. So now you can see we have to find the value of my dash of 0. Okay, so let me rub it. Okay, so we have to find the value of m dash of y at 0 because this will provide us the value of expectation of y. Now from here you can see everyone what I can write at the place of this. I can write I can write mx dash of f of 0. This is what we got in the above lines, and f dash of 0. Now let me show you. See, this is what I am talking about. Now here we have to substitute t is equals to 0. So now you can see I have substituted t is equals to 0 here, and by mistake I have written here theta, but it is your 0. Now we have the value of m dash f of 0 in the above line. You can see this is 2. So here I am putting 2 into what is the value of f dash 0. Now you can see from here the value of f dash 0 is also 2. So going to substitute this value here. So what we are getting? We are getting 4. So now you can see everyone in the question, it is coming in option number C. So I think option number C is the correct option. You can also check the correct option in your answer key section of your UPSC. So now you can see this is the whole question number, the whole solution of question number 16. So I hope you all like this solution. Please do let me know one thing, because I have already posted a video where I have chosen white background. Okay, now this time I have chosen the green background. So which one suits you better? Do let me know everyone if you want to join my live classes. The link and the phone number is given in the bio, as well as you can contact me on Instagram. So thank you everyone for watching this video. Have a nice day.